On a roller coaster ride, passengers travel in carriages around a track, and the ride carriages complete multiple circuits of the track, such that the maximum vertical height of the carriage above the ground is 60, and the carriage starts the circuit at a vertical height of 2 meters above the ground, and the ground is horizontal. The vertical height is then modeled by this. It's a quadratic. Okay, now again, somewhere we can sketch this quadratic. So it's going to have a minus t squared, or minus bt squared as its leading coefficient. It's going to be an unhappy or upside down quadratic. Now, when t is 0, we're going to just get some value. It's not going to go through 0 or anything. But when t is 20, that's when it's going to hit its maximum. I'll talk a bit about this now. It's because the t minus 20 all squared is always positive because I'm squaring a number. It can't possibly be negative. But then when I make it put a minus in front of it, this term is going to be less than or equal to 0. It's always negative or 0. So the most that the function could ever be would actually be a, because otherwise we're subtracting something from it. The maximum is going to occur when we're not subtracting something from it, so when this thing is 0, so when t is 20. What I'm saying is it's going to come up and go back down, and it's going to hit the maximum at 20. So find a complete equation for the model. Actually, we can straight away say that a is going to be 60, because remember I said it's when this term disappears, we get our maximum, and we're told the maximum is 60, so a is 60. Then for the other part, I'm going to substitute in t equal to 0, because it says t seconds after the carriage starts the first circuit, and it also says a carriage starts the circuit at a vertical height of 2. So I can write down that 2 is equal to 60 minus b times minus 20 squared. That becomes 2 equals 60 minus 400 b. And if you solve for that, you get b is equal to 0.145, which gives us our complete equation. H equals 60 minus 0.145 t minus 20 squared. Use the model to determine the height of the carriage above the ground when t is equal to 40. Now there's a really quick way of doing this one, and it's to spot that the line of symmetry for this quadratic is at t equals 20, and 40 is exactly the same distance away from 20 as 0 is. So we're going to hit 2 meters at 0 and at 40. 2 meters is the height here. If you don't spot that, then don't worry. You can just substitute 40 into the equation that we had, and you can see we're going to get that. Instead of minus 20 squared, we're going to get 20 squared this time. But when you substitute in, you're going to get that value of 2. Now, in an alternative model, the vertical height of the carriage above the ground is given by a trig equation, where alpha and beta are constants. Find a complete equation for this model. I'm going to, first of all, substitute in t equals 0 this time. So 2 equals 29 cos alpha plus beta. All right, I've got alpha and beta. It doesn't quite cancel out in the same way it did for the quadratic. And then I'm going to put 60 in, which is 29 cos 9 times 20, so 180 plus alpha plus beta. And I'm going to try and solve this equation. Now, here's cos. And if you take any value on the cos curve and then just add 180 to it, it actually takes you to just the negative of whatever you have before. So I can replace this by minus cos alpha. If you don't see that from the graph, then you could use your addition formulae. So cos A plus B is cos A cos B. So in this case, cos 180 cos alpha minus sine A sine B. And sine 180 is actually 0. Then cos 180, so we see here is minus 1. So I've proven using addition formulae that this is true. Back to my two equations then. I've got 2 equals 29 cos alpha plus beta. And I've got 60 is equal to minus 29 cos alpha plus beta. So I'm going to add these two together to start with. 62 is then going to be 2 beta. Beta is going to be 31. And then I might as well just subtract them the second time around. I could put in beta back in, I guess, but let's subtract them. Then I'll get minus 58 equals 58 cos alpha. Cos alpha equals minus 1. So alpha is going to equal 180 if I do inverse cos, but you can also just see it from the graph here. And therefore the complete equation is h equals 29 cos 90 plus 180 plus 31. Finally, given that the carriage moves continuously for 2 minutes, give a reason why the alternative model would be more appropriate. Now we can see with the alternative model, it's just going up and down and actually just continuing like this repeatedly, so that kind of makes sense for lots of circuits. So as long as you kind of talk a bit about that, I would also mention that the quadratic meanwhile actually just becomes more and more negative as t increases. So as long as you write some words down along those lines, that's okay. I actually said the alternative model oscillates. I should have probably said, therefore, this model's a repeated root, whilst the original continues to decrease after t equals 20. That's what I said. Here's some things from the answer. As long as you kind of talk about multiple cycles, repeated circuits, cyclical, any of these things, after 2 minutes, the carriage will be back at the start. The original quadratic will become negative. You could even put in some values of t and show that it's the quadratic one is going down, whereas you could also do it for the alternative model and show that it's actually cycling. So yeah, something along those lines to finish this off. Well done.